Assalamu alaikum and welcome to all viewers. My name is Akil Abbas and you are watching the Ilm Academy. Today we will discuss different types of the vector. Before starting, you must know vector and how it is represented in the 2D plane and 3D space. So go to my lecture on 2D plane and 3D space by clicking on the card showing in the top right corner of the screen. So let's start our lecture now. 5 types of vectors are flashing on the screen. We will not discuss position vector yet in this lecture because to understand them we must have some additional knowledge of the basic concepts of vectors. Let's first discuss the null vector. The vector is defined as a vector of zero magnitudes and with arbitrary direction is called null vector. Question here, what is the meaning of zero magnitude and arbitrary direction? Let's understand with an example. Here we have a 2D Cartesian coordinate system with which you people are very familiar. Let a vector move right from the origin toward the positive x-axis. This vector is indicating that it has some magnitude under a certain scale and a specific direction. But what will happen if I start reducing its magnitude to 0 in reverse, mean taking that vector at the origin? You saw at the origin the direction of the vector which was indicating in the green arrow vanished because at the origin a vector always represents itself as a null vector. Confused? Let's make it easier. I am drawing a point at the origin that is indicating a null vector as it has zero magnitude here. Now I ask you where this point's direction is. Can you guess? Definitely not, because if you say right then it could be left, or if you will say left it could be up or down in any direction. Until or unless it will start moving, we will not guess that what is the direction of this vector. So this is what the meaning of arbitrary direction is. The null vector is denoted by O with an arrow on it. It is used to balance vector equations. For example, if vector A is equal to vector B, then vector A minus vector B is equal to the null vector. Let's move toward the unit vector. It is defined as a vector whose magnitude is equal to unity and specified for the direction only is called unit vector. Let's understand this with an example also. Let there is a vector A. What the two things are that made this vector? We all know that magnitude and direction. If I separate these two, let's see what will happen. We have a line of certain scale that will be called magnitude of vector, at which if I just see, I could not tell from where this line started, either from left to right or right to left, and an arrowhead which is indicating direction. The arrowhead is a unit vector which is specifying direction, where its magnitude, its unit vector's magnitude is a unit as compared to the whole scale of the vector. So we can conclude that the unit vector has a direction same as that of the given vector. It is denoted by a letter with a cap and is read as A cap or A hat. Now we can design the equation of vector as vector A is equal to the magnitude of vector A multiplied by the unit vector. Keep in mind, a unit vector has no units and dimensionless vector. Those viewers who did not watch my lecture on dimensions can click on the card showing in the top right corner of the screen. Finally, the unit vectors along the x, y and z axis of the three-dimensional Cartesian coordinate system are represented by unit vectors I, j and k. The magnitude of each of the vector is equal to 1. Now moving toward equal vectors. Let's take two vectors a and b have the same magnitude and direction. In other words, we can say parallel vectors, and more precisely, we can say the angle between both vectors is 0 degrees. These two vectors will be said to be equal vectors. So we can define equal vectors as vectors which have same magnitude and direction regardless of their positions are known as equal vectors. What does regardless of their position mean? It means both of these vectors are equal, either they start from the same point or origin or at different points, but two things they must have to be equal vectors. And what are they? Same magnitude and same direction. Now negative vector, which is defined as a vector which has same magnitude but opposite in direction to the given vector, is called negative vector. For example, we have a vector A with a certain magnitude. Let's suppose another vector just like A means the same magnitude but exactly opposite in direction, or can say at 180 degree to the vector A. This vector is denoted by minus to the vector A, where the negative sign is indicating that this vector is anti-parallel to vector A. This is the end of our lecture. I hope you liked this video and learned something new. Share this video and subscribe to the channel. It took a lot of effort to make such an interesting animated lecture. Now I will meet you in the next video. Take care of yourself. Allah Hafiz.